Hello guys. Today we will discuss about one of the most frequently asked coding question in almost all the languages. As a newcomer, so this is the question which you can expect. So what is that is write a program to print the list of prime numbers from a given range. So I am taking here from 1 to 100. List of prime numbers from 1 to 100. So then what is the concept or logic behind this one? Before we go for coding, let us understand the logic behind this one. So what is a prime number? So in our mathematics, we are aware of this, the meaning of prime number. It is nothing but any number which has exactly two factors. A number which has exactly two factors. So we call it as prime number. Correct? Yeah. So this is the information which is enough for us to understand what is the logic behind this one. So to understand this logic, so first we have to consider each and every number from 1 to 100, correct? So here I'll go for, I'm considering number 1 and number 2 and 3 and 4 for our clear understanding. Then and so on, it is the same thing which will be applicable for remaining numbers as well. So up to 100. Now to convert the same step into the corresponding code, to have a number from 1 to 100, can we generate a corresponding loop for this? Yes, we can have easily generate loop for this one. So for this, I'm just using a for loop, and int is a type because these are numbers. I'm using a variable called I, and to start that loop from 1 and then followed by I, and till where we have to continue the loop till 100. So when we check with 100, all the remaining numbers are less than 100. So therefore, I'm using the less than, and since we also need to include 100, then I'm writing less than and equals as well. Then followed by I plus plus, because each number has to increment by 1 at every time. So this is the for loop starting, and somewhere I'll end this for loop. Yeah. So then inside this, what is the next thing to write it? So for that, let us understand the concept. So if we consider 1, then to check this 1 is a prime number or not, we have to divide with the numbers which are equal to this and which are starting from 1 as well. So for in case of 1, it is less than this number or equal to this number, it is same number as 1 only. So division, I'm using a modulo division operator. And if we check with 1, if the remainder is 0, then can we say it's a prime number? No, we cannot say, because we have to count the number of factors. So if it comes to 1, then we have to verify 1 is divisible by 1 or not, and 1 is divisible by 2, it's not required. More than the number which we consider is not required to check with those factors. So this is the only one scenario when it comes to 1. What about 2? When it comes to 2, with 2, we have to divide and check with 1 and it's a factor or not. And for 2, even we have to check with 2 as well, even this is a factor or not. Correct? So then do we need to go for dividing 2 with 3 to check? No, this is not required because this is more than our number. That's the reason this line of step is not required for verification. So what I mean to say is, for every number we have to start checking with 1 and we have to stop when that number is equal to which number we are considering. That's what I mean. I hope it is clear. Similarly for 3, what we have to check? We have to check for 3 with 1, and then we have to check 3 with 2 as well, and we have to check 3 with 3 as well. Then do we need to check 3 with 4? Again, it's also not required because starts from 1 and end with equal to the number. Similarly for 4 we have to check with 1, and then 4 we have to check with 2, and then 4 we have to check with 3, and also 4 we have to check with 4 as well. So in this process of checking, what we have to do? We have to count the number of factors. So for every number, to decide it's a prime number or not, we have to count its factors. And even for the next number also, we have to count corresponding number of factors. It means whenever we are dividing 2 with 1 and 2 with 2, how many times is the remainder is 0 or not? That's what we have to count it. Similarly for 3 as well, we have to find the count as well. And 3 is divisible by 1, then 1 time it is yes. 3 with divisible by 2, no. 3 is divisible by 3, yes. Similarly for 4 also we have to count, and yes, yes, no, yes. So therefore we get the corresponding count. So once we get this count, that means how many times the remainder is becoming 0, then if that count is exactly 2, then we can conclude that the corresponding number is a prime. So in this example, 2 is having how many factors? 2 factors, that is 1 and 2. Both the times we get the remainder as 0. Therefore, count will become 2. And when it comes to 3, the count will become 3 is divisible by 1 and not divisible by 2, and yes, divisible by 3. Therefore, count will become 2 again. When it comes to 4, 1, 2, 3. Therefore, count becomes 3. When it comes to 1, count will be 1 only. So in this and with this understanding, so we have to conclude that 2 is a prime number, 3 is a prime number, which we are aware of, whereas 1 is no because it's less than 2 factors, and 4 is also no because it's more than 2 factors. So now for the same thing, I am going to write the next loop. We consider these numbers 1 to 100 with this first for loop, then to check with each and every number by starting with 1. Each and every number to start with 1. So for that, again, I am taking one more for loop. I'm leaving wantedly some place to understand the next points. So for loop, int, can we use the same variable I again? No, because we are inside the same for loop. Outside for loop variable is I, so we can't go for same I again. So I am choosing a next variable j. And why I am using 1 to start with? If you just notice this step-by-step process, so here 1 and 1 and 1 and 1. For each and every number, we have to start checking with 1. Yeah. Then followed by where each iteration has to end. I mean, for 1, it is ending with 1 only. For 2, it's ending with 2. For 3, it's ending with 3. For 4, it's ending with 4. It means we are starting from 1 and we are ending by equal to the number. We are starting with 1, it's ending with equal to the number. It's the same thing even for 2 as well. That's where I'm writing j should be less than or equals to I value. Correct? Hope you understood. Then followed by j values. That means 1 after 2, then 1 after 2 of 3. Then it means it is also incremented by 1. So this is the inner for loop. Nested for loop concept I'm using here. For loop body, inside that one more for loop. That's we call it as nested for loop. So here is the starting of inner. And here I'm taking the ending of the inner. So inside this, what is the sequence of step-by-steps which are happening? This is first iteration, and this is one more iteration, second iteration, I mean, and third iteration, and fourth iteration. Like this, 100 times it has to iterate. What is the step-by-step process which is happening? If we take this 2, 2 is there in which variable in this loop? I variable. Correct? First 1, then followed by 2, then 3, 4. These values are there in I variable. Then this 1 is there in which variable? And this 1 and this 2 and this 1 to 3, they are there in the j variable. Therefore, I am writing the condition if I value modulo j double equals to 0. Then inside this if body, so starting of the if condition, ending of the if condition. Inside this, what we have to write? Can we write directly that it's a prime number? No, we have to count the number of factors. That means how many times the remainder is becoming 0. We have to count it. So for that, I am taking count plus plus. This is t, then followed by plus plus symbol. Count plus plus. Then to increment the count, I'm using a variable count. But in this program, did I initialize this anywhere? No, right? And if anybody is thinking that if we have to initialize outside this for loop, count with its corresponding data type, say int count to initialize to 0, then this is inappropriate location. This is inappropriate. If we initialize here, even though some numbers are prime numbers, we don't get the expected output. Okay, this is not the proper place. That's why I left some space here. So here is the proper location where inside the outer for loop, outside the inner for loop. So that is where I'm going to take this int count equals to 0. This is the appropriate location for count variable. Then here we can use the variable without again data type here. So this is the purpose of inner for loop with if condition and incrementation of count. So after every iteration, what we have to do? We have to check the number of factors are 2 factors or not. If it is 2 factors, what we can say? We can print that number is prime. Correct or not? So for that, I am writing where outside the inner for loop, still inside the outer for loop. So here is I am checking one condition. So if count is exactly equals to 2, then we have a conclusion that, so inside this, I'm writing system.out.println, a short form I'm writing. So inside this one, in which variable these values are there? Like 1, 2, 3, 4. Is it an I variable or J variable? I variable, right? So then I, then with plus operator, I'm writing I space is prime. Then end of double quotes, end of print statement parenthesis, then semicolon. So this is the code which gives the logic, which gives the output of prime numbers list from 1 to 100. Like 2 is prime, 3 is prime, 5 is prime. So that is the expected output which we get from this program. Yeah, I hope it is clear. Let us also execute this program through the IDE Eclipse and we'll cross verify the output. To understand the same program and to cross verify the output, so I am using the IDE called Eclipse. So inside this Eclipse, I have taken a class and also corresponding main method for execution directly. So here I am writing the same discussed code. So what is our requirement or what's our program? So here we are writing a program. So write a Java program to print list of prime numbers from 1 to 100. Right? So for this program, whatever we discussed, the same thing I'm going to type here. So first we need one for loop. Before this for loop, we don't need any external variables. So I'm not taking anything before. So int I equals to start with 1. And we know that it has to be checked from 1 to 100. Then for every number, so I'm writing I plus plus. So this is the outer for loop. Inside outer for loop, what is the first line of code which we discussed? So we have to take one count variable and initialize to 0 is the appropriate location. Yeah. Then followed by, we have to consider inner for loop. So for j values to consider. So j is also int type again. So variable name j. J has to start from 1. Then j has to end. J should be less than or equals to I value only. For every number, it has to start from 1 and it has to end when it reaches to the equal value of the number. Then j should be incremented by 1 every time. So therefore, j plus plus. Inside this inner for loop, what's the code which we discussed? One if condition, right? So here, if condition, what is the condition? We have to check every value of I. So for that, how many factors are j? The factor means the remainder should be 0. That's why double equals to 0. So this is the for if condition. Inside this if condition, what we have to write? We have to increment the count. That is count plus plus. Then where we have to print it's a prime number or not? So this is the end of inner for loop. So then this is the end of outer for loop. So here is the location after inner for loop, before outer for loop. So here is the place where I'm using the condition. So when we can decide it's a prime number, if count is exactly equals to 2. So in that situation, we can say that system.out.println that I value I'm appending with a message called as is prime. Yeah, let me save this program and let me execute this program by clicking on this shortcut button. So now you can just notice. So we got the list of prime numbers from 2 to 97. So this is the expected output, and also our code is giving the correct output. Just now, I mean, while discussing, I said one point, right? This is the appropriate location. If we initialize this count variable outside the outer for loop, I mean, here is the place where I'm taking. Let us cross verify. So int count equals to 0 I'm taking. Yeah. So now let me save this code and let me execute again. Now this time, are we getting anything in the console? No, no output. It means if we initialize count value equal to 0 here, then there is a concern that for every number which we consider, count value is not becoming 0. I mean, when the cursor goes to number 2, count of first value also will be included in that. That means, so in the code, if you just remember, 1 has one factor. 1 has one factor. And here, what's the value of count? This will become count as 1. Then when for 2, it's the same iteration is happening. Here also, this is, yes, factor. Therefore, count will become plus 1. And then for 2, 2 is also factor. Then for this, count is becoming plus 1 more. Means once the end of division process done for number 2, what's the value of count is becoming? It is becoming 3. Then is it equal to 2? No. That's why we are not getting the output as 2 is a prime number. But is 2 is not a prime number? Yes, 2 is a prime number. So, but because of this initialization, this is the process which will happen internally. Therefore, we are not getting the correct output. That is the reason behind this location is incorrect. This location is incorrect to initialize our count variable. So let me comment this line number 7 and let me enable this line number 11. So now let me save once again. And will it work for only this 1 to 100? No, it is our logic is generic. It will also work from 100 to 200 as well. I'm just changing the input to show you the output for generic or not. So now let me save this code and let me execute from here. So now 101, 103, 107, all the list of prime numbers from 100 to 200. Yeah. So this is the complete generic code of list of prime numbers from 1 to 100 we discussed, and from 100 to 200 also we cross verified. Yeah. Based on this logic, we can also write the programs for given number is a prime number or not. And also nth prime number we can print. Sum of prime numbers we can print from given range. So all these things we will discuss in the next video. So thank you so much.